Oh, geez. That's how good they were. I don't know. What do you think about that metal nails through concrete? Fairly excited. Was it the Structural Engineering Podcast?
Hey, welcome to this week's episode of the Structural Engineering Podcast. My name is Max.
And I'm Zach. And this week is episode 2 of our 2-part series on tornado engineering. This week we sit down with Mark Kaiser, an associate engineer with RLG. And we're really excited to give you a whole different perspective on tornado engineering. I think he has a little bit different perspective and some more information to provide to you guys.
Absolutely. So without further ado, let's get to it.
My name is Mark Kaiser, registered structural professional engineer. Been practicing since 2006, so 14 years of experience. Do have a lot of experience designing storm shelters, especially here in the Dallas area. I work for RLG Consulting Engineers. We are a civil structural forensics and offer surveying here in the DFW area.
Nice. And are your projects around the country, or are you mostly in the Texas area right now?
So for RLG, we do projects nationwide. We do actually do have a lot of projects actually in California, which has been still fun to practice the high seismic stuff. Vast majority of them are here in the DFW area.
Cool. Yeah, we're going to talk about the ICC 500 quite a bit. I have a handful of questions for you. I haven't used it all that much, so hopefully these aren't ridiculous questions, but you kind of mentioned that there are some changes to the ICC 500 when it was adopted by the IBC, and that's kind of the first stuff I want to touch on. So the ICC 500 first published in summer 2008, updated kind of recently, 2014. The IBC, as we know it, was a combination of all these other regional codes, and in the 2000, I think, right, it became the ICC. Was there something before the ICC 500?
Yeah, so the way this kind of started was before 2008. If you wanted storm shelter, let's call it guidance, FEMA put out a document called FEMA 320. And that was basically, it was called Surviving the Storm. And what it gave was it was a booklet, a design booklet that helped people to build residential storm shelters based on kind of like it's a prescriptive approach. So therefore, if you're interested in having one as a resident or maybe an owner of a small business, and this was kind of limited to 16 occupants, that was the only kind of official resource out there for you. Wow. And it actually even gave you drawings, like kind of design basis drawings that you could use to build your own storm shelter.
Really?
Yeah. So if you go, you can actually Google search it now. They have updated it. It's been updated since then. Just do a simple Google search of FEMA 320, or you can even see FEMA 320 drawings, and you could see basically FEMA blueprint drawings of how to build your own 16-person capacity storm shelter.
All right, what do these plans look like? First off, let me say, if you haven't designed a storm shelter before, this is an excellent place to start. FEMA provides what are essentially construction documents for the design of several storm shelter types. The design documents they give cover an area of an 8x8 square all the way up to a 14x14 square. Details are provided for wood structure with CMU infill, strictly wood frame with double stud and double sheathing, CMU, concrete, and even ICF, insulated concrete forms. In addition, if you're a student and have limited exposure to construction drawings so far, these things are laid out really well with lots of details, complete general notes for the design specs, so they're worth checking out. So what would you do if you wanted more than 16 people, like something for commercial use? Or
and so that's kind of what ended up happening. And there was if you look at how this whole history of this whole thing has happened, in May 1999, there was a Oklahoma City area tornadoes that basically it got widespread media coverage. And now people started like, hey, what are we going to do with this? We really want above grade or even below grade storm shelters. And so as the genesis of that, they organized the National Storm Shelter Association. So that was organized kind of after this event. And then task force was kind of put together to come up with some standards, how we're going to address this scenario. How are we going to design for, a storm shelter for what's called the community shelters? Anything that's above this whole 16 occupants are not just going to serve residences. So with a lot of testing from Texas Tech, they've been very instrumental with this. They've kind of started putting this all together kind of in the early 2000s, let's say, when they started coming up with these ICC 500 requirements of what they're going to end up coming to be. And I think that came together in 2002. So if you actually go to the National Storm Shelter Association website, they do give a pretty good history of how they, came together, how their board of directors was established, how they came up with a committee of how to tackle this whole scenario. And then them, along with the International Code Council, came up with what was ICC 500, and that was the standard. They basically developed the standard, and it was finally approved back in the 2008, and that's how you got to where you were.
I won't read you the entire NSSA history, but I'll give you the beginnings. Research into improving buildings for resisting extreme winds began after the 1970 Lubbock tornado. A third of the city was destroyed in this event. A few years later, in 1974, the first above-ground storm shelter was presented in Civil Engineering Mag as a product of Texas Tech. Interest in storm shelters boomed again after the 1997 tornado in Gerald, Texas, which destroyed an entire subdivision and received plenty of news coverage. Above-ground storm shelters were a feature of many news stories, which led to an increase in interest. To respond to this new storm shelter enthusiasm, FEMA 320 was organized.
There are other documents. In addition to that P320, they also have 361, which does cover specific community storm shelters and safe rooms, which it basically everything that's in ICC 500 is also in that FEMA 361 document. Plus, it goes a little bit further and has some more conservative approaches because it's intended to be a safe room, not just what's been codified as a storm shelter.
So when we went from the FEMA 320, 16-person, smaller kind of occupancy, to the ICC 500 with, a lot more purpose to it. Were there any changes? Like if you were to build a small storm shelter that was similar to the 320, is it a lot different now than it was then?
Well, yeah, because now you've got the ICC 500 is geared towards what's called these community shelters. It certainly does still tackle some residential shelters that has that information in there. But this is the first document that tackles the community shelters. So in there, you've got minimum square foot requirements per occupant, whether they're standing seating or they're bedridden or wheelchair bound. So now you've got, a usable floor area requirement that you need. While some of the loading requirements are pretty much, the same, like a roof live load of 100 PSF minimum, that's now, put into a design standard somewhere. Mm-hmm. Same thing with the wind loads. What are you using when you're doing your wind loads? Yes, you're using, depending on where you're at, 250 miles an hour is what's typical around this area, or what we generally think of Tornado Alley, because that's what the EF5 tornado is. But then what do you use for your internal pressure coefficients if we think back to how we develop wind loads? So for the most part, the standard is to use a partially enclosed building. So you've got your internal pressure coefficients. Same thing, rain loads, that's talked about in there. And then it covers a lot more of how do you, address, power to this thing. Because in a typical residential, shelter, they don't really worry about power so much because you only have a few people in there. You have a vent pipe and you got, your air that you need. Well, now that you're putting hundreds of people in here, you need to somehow keep ventilation going. You need to, emergency illumination. So now that we have this ICC 500, it pretty much gives you that bare minimum that was in there for a community shelter to serve hundreds of people, as opposed to just the 16 people.
Yeah.
So in addition to, let's call it loading requirements, there's also, MEP mechanical, electrical, plumbing requirements, and then just general architectural requirements for egress, and let's just call it operational requirements of how we're going to run this thing for up to 2 hours after the event.
2 hours is kind of the amount of time expected to clear out.
Yes. So in ICC 500, basically anything that's required to operate a storm shelter must be operational not only for the duration of the event, but for up to 2 hours after the event.
I'm curious if you know off the top of your head, when you were saying the space required for standing, sitting, how is this, very tightly packed? Can you make these? What's the square footage for a standing person?
So, no, not a problem. So yeah, they give you a table for it, and it's basically in the chapter 5, which talks about, your occupancy, means of egress, and accessibility for your storm shelter. So community storm shelters, for a standing or seating person, you're limited to 5 usable square feet per occupant. So that means no furnishings type thing. It's just 5 square foot of just clear space for that person. If you're wheelchair, it's 10. If you're ridden, it's 30. And then it also covers hurricanes. So for hurricanes, since those are typically longer durations, your square footage requirements go up. So if you're for a hurricane storm shelter, or storm shelter designed for hurricane, you're up to 20 square foot for a standing or seated person, because we're talking something that could last for days, not necessarily, just that quick.
Yeah. You don't be standing like you're in a subway for 2 days.
Exactly.
I mean, 5 square feet is tight. I get that. That was sort of what I was expecting, that it would be, for these short duration events, but man.
Yep.
That floor area is tight, but there's one additional point that may at least help the space feel bigger. The usable space isn't just the gross area between the structural walls. The gross area must be reduced by between 15 and 50% to account for different furnishings and partition walls. In a real crunch, you can calculate the actual area of chairs, columns, any equipment, and remove that portion from the gross. So with the newer IBC codes 2014 on, storm shelters are now required in educational occupancies and critical emergency operations centers in areas prone to extreme tornadoes. So do you think this has increased the prevalence or the rate that you're seeing storm shelters kind of generally?
Oh, yes, for sure. Basically now, if you're doing an educational facility, you are required to do it. If you're adding reasonable square footage to your, let's call it, existing campus, you are required to do it. It's now per code. Anytime you're doing significant renovations to a 911 call center or a police station or a fire station, you're having to add this in there. I have yet, I think jurisdictions now, especially in these tornado-prone areas, especially let's say here where we just had one just a few months ago, come right through. Let's call it Dallas proper. Mm-hmm. People want these things, and they are being constructed. There's not many people who are striking them out like local municipalities saying, "Hey, yeah, we understand it's in the building code, but we're not wanting to do it." So it's something that's very real, and it's impacting not only ISDs, but it's the charters and private schools too. It's everything that needs, all of these things
educational.
Yep. Wow. What I do always find interesting though is it doesn't, come up to higher education. Because that institutional type stuff kind of is treated in the building code more like commercial, not necessarily like the the standard, like let's call it K through 12 education. So it is a little bit interesting that it hasn't come up there yet, or that they're not, required to address it in those regards. But they have the amount that I've done over the past since 2015. Pretty much every school project I have done, minus if we're doing like an ancillary gym structure on a campus, does require a storm shelter.
You'd said that no municipalities aren't, crossing out that this is a requirement. Are there any modifications like you might see when I was working in Colorado? A lot of cities or something would generally increase the minimum wind speed in their area. Are you seeing any modifications to the IC 500 document on a local level?
No, not too much. I think early on there was some people tackling with some of the mechanical requirements that they thought were maybe a little too stringent of how to handle keeping things fully functional, or how to handle some of the mechanical operation requirements where you have to provide potable water and sanitation for that same 2 hours after the event, and how do you reasonably accomplish that? And so I think there was a little bit of give and take, but there wasn't any like big relaxations. I mean, I think everybody around here was like, nope, let's just go ahead and follow this to the T, because we know at least this is the standard we have, and this is how we're going to approach it.
Yeah. And then I guess the other question I had for you when talking about, schools, and that people are kind of asking for these things. Are you seeing that? Like, do you think there's a feeling of, I don't want to send my kid to a school that doesn't have a storm shelter of an adequate size? Like, is the community pushing back on this a little bit to make it happen?
Not that I've heard of yet, as far as that kind of scenario goes. What will be interesting is to see how a lot of the rebuild stuff goes around here, because we did have two schools that were like in the Dallas area that were heavily damaged. Actually, really? Now I think about two Dallas ISD schools, and I believe one private school was heavily damaged. And I know as they have to rebuild, those will become a part of it. Now, what will be interesting is those new campuses will have to be fitted with said storm shelter. And anytime they do renovations, they come by. But I don't know, given taxpayer dollars and all that stuff, how people are going to feel about how do we pay for these to get them on there sooner rather than later, because they are expensive building components to have, since you're designing something to withstand up to 250 miles an hour of wind pressure. Or I'm sorry, wind speed.
Speed, yes.
Yeah.
Here's a question that I botched that I'll reword for clarity and with some more context. Mark did a good job figuring out what I was getting at, so I think the answer fits. If you've listened to any of our episodes about seismic resilience, you'll know that it's a well-understood idea that ideally, a community should have the ability to absorb damage while still maintaining its critical infrastructure and be able to rebuild quickly. This is get the power back on, don't disrupt the water supply, keep hospitals open, etc. Resilience is a holistic idea, but a part of it is keeping critical buildings lightly damaged. The U.S. has lagged some other more seismic countries such as Japan, Chile, and New Zealand in embracing really advanced seismic design. For instance, base isolation. I had hoped that due to the higher frequency of tornadoes, we might see either a resilience mindset in community planning, or at a minimum, a lot of people demanding storm shelters where they live and work. One big thing I didn't grasp while recording these episodes is that while actual tornadoes are frequent, the chance that your building will be hit by one are so small.
I mean, realistically, you think about it, especially in some of these, in just to consider the life cycle of your general building. What are the odds of, and I say this fully understanding stuff happens, but, the odds that your building is going to be hit by a tornado are still, look at those odds. They're very small. And that's even you look at as a practicing engineer, you look at just if you read the commentary of ASC 710, they basically said the effects of tornadoes are outside the scope of this. Because in the grand scheme of things, if we take a step back and look at a 10,000 foot view here, the odds of your standard building being hit by a tornado are very small. Now it does happen, but a lot of times these also happen in very rural areas too, where the loss of these types of, I guess, structures they're not as prevalent. But with that being said, you have more Oklahoma that's happened. You do have these cases that, do happen. But it's still, you take the probability of it. It's not as great as what you think. If you go back through and do all studies of it. Now, the flip side of that, with that being said, I have done office building projects. What we have seen down here is you have people who move to the DFW area, or let's call it the Oklahoma area. What you think of traditional tornado alley? They're moving out of, let's say, California, where they were worried about earthquakes, but now they're, hey, there's tornadoes there. We need to address it. So I have had these conversations with developers or, people wanting to put their new office campus in the DFW area. Says, what can we do to do it? And we have those conversations with them. We kind of walk through them. Hey, how do you want to handle it? And, here is the realistic cost implications for it. And, you have a contractor that helps them understand that, and they make an educated decision from them. So what has been interesting is when you're coming into these developments for, let's call it just your standard office campuses, it is becoming top of mind of people that are moving to these areas where tornadoes are prevalent, and they are trying to address it in somehow. They probably are not going to the extent of ICC 500, but they're trying to address it in some way.
Interesting. I mean, that sort of makes sense from the way that the perception on the news, right? You live kind of in that environment, and the odds way better than I do. I see only the worst case in the news, and it's infrequent, but that doesn't really occur. It's just like, oh, look at that tornado, look pretty bad. I would like a storm shelter in my house, but the reality is goes over my head.
Yeah, and you think about it is, okay, so then now you'd like one too, but can you even afford to put one? They're not, they're not cheap to build. And but there are other things. I mean, you look at, it's kind of funny. You go to Lowe's around here, and there's times where they have a metal or this steel tube looking section where you can buy a prefabricated storm shelter that bolts down to your garage slab. So you can get one. There are ways to have one if you want one. But like I said, in the grand scheme of things, and if you look at the probability, and it's easy to do, look at the statistics. The typical building is not gonna. The odds are it's not gonna see a tornado in its lifetime.
Let's talk briefly about where we are most likely to see tornadoes. The common term tornado alley includes areas of Texas, Oklahoma, Kansas, South Dakota, Iowa, and Nebraska. However, generally a few tornadoes will occur in every state in the U.S. on a given year. Texas may see 155 per year, while Maine receives only 2. The U.S. as a whole sees on average 1,253 tornadoes per year, the most of any country, while Canada being a distant second at 100 per year. The ICC 500 provides storm shelter wind speeds for about 2/3 of the country, basically everything east of the Rockies. All right, so if we're looking at the occupancy load of a storm shelter, and we've got a large building, I did get to look up some pictures of larger storm shelters, and they look impressive. What does the shelter need to fit every possible occupant of a building, or is this like a percentage of how many people could be on site?
The way it's written, it's got to serve the total occupants of the building. So what does that mean? There are I've had talking to different clients to come up with what is that occupant load you need to do it for. And so one scenario is, do you have a giant auditorium in this campus somewhere? Because the odds are, well, that could be filled up at some point, and that could exceed the student capacity, student and teacher capacity of the, let's call it just the educational building. So that could set how big you're going to end up getting where you need a storm shelter. Because if you're having an after school event, like a play, and you have everybody that's inside that auditorium, in theory, if a tornado comes, they would need to seek shelter in that. They would want to seek shelter in that storm shelter. I have heard arguments where your state, guidelines require a certain amount of students per classroom with a certain amount of teachers. Well, that could set your occupancy low because per state requirements, you cannot have this many students in there. But then you can always go to the IBC. I'm trying to remember specifically what chapter it is, but basically, if you have something that's designated educational occupants, you can have so many people in that room per square feet. Well, then that's how you get your occupant load of your structure. I do know you don't have to double count. Like if you have a cafeteria, it's not like you have to fill up every possible thing. I mean, because that's a dual use, right?
Yeah,
so,
it's got to be realistic.
Exactly. Same thing with the gym. You can't have everybody in the school plus everybody in the gym at the same time. So basically what you do is you look up any office or let's call it classroom building that's associated with Group E occupancy. You have the square footage requirements for that. How many occupants can you get in there per square foot, not counting your double use like multi-purpose rooms, cafeterias, and stuff like that. And that's how you come up with what your load is. Or if you can go that route with the jurisdiction, say, listen, per state requirements, it's only 23 kids per student. So you've got, or 23 kids per teacher. Well, here's our classrooms. Here's how we have. Same thing with your offices. You're given a certain per occupants per square foot of office space. You add that all up, and that's where you come up with what your occupant load is.
Okay.
So, and then given the tables in ICC 500, you have that 5 square foot for 5 square foot per occupant requirement for standing. Well, you got to keep in mind that's usable square feet. So, when you're looking at your gross square footage, obviously there's some square footage is going to be unusable. So you have to take a reduction and come up with what your usable area is for your occupant load.
Yeah, that makes sense. All right. I've only designed a couple little storm shelters, but I remember that like structure-wise, it gets pretty intense. What storm shelter from structure standpoint look like for 100 plus people? Is it lots of little, a 250 mile an hour wind? Like we had, I forget how thick this roof was, but like fully grouted CMU walls. What does this look like on a bigger scale?
So what I will say is it all kind of depends on what the purpose is, because what we don't have is, what I would always say, the holy grail as a structural engineer is the storm shelter that's built away and is only going to serve as a storm shelter. It's basically, for its function.
Yeah.
But that's not going to happen. Never. Yeah. So everything's dual purpose. So if we're talking about a gymnasium, because a lot of people really like the gymnasium, a lot of people initially go to the gymnasium approach because you have a big wide open space where you can get people in there. What does that start looking like? Well, given your tall walls and long spans, you have to meet the missile impact requirements that are in ICC 500. So it's basically a 2x4 missile, hit it going at 100 miles an hour at a wall surface. So you have to meet those impact requirements, and then you have to meet the wall pressure requirements. Mm-hmm. So for something like that, you're looking at, a concrete solution, whether it's precast or tilt up, or what's becoming very popular right now is insulated concrete forms. So you have a minimum, you have to at least meet a minimum wall thickness for your missile impact protection. But then after that, you have to consider your wall pressures. So that's how you're going to get, kind of what your wall assembly is going to be. You also have to consider your vertical loads from your roof. So at a minimum, if for the most part, we always like to add dead load to resist the wind uplift pressures that are there. So you're, for the most part, going to do some sort of concrete roof system, whether it's if you're going a precast approach, there's precast double T's that can usually span something like that for a gymnasium. Or you can go to composite. You can go to composite construction where you have a, minimum, 4-inch of concrete topping over, let's say, a 2-inch deck, so a 6-inch total assembly, and then use composite steel joists, very deep composite steel joists to go over that, or composite or just trusses to carry that load. But you're basically doing a concrete and something that. Now we've also seen a lot of let's call it single story applications where we do get the benefit of the let's call it cheaper construction of masonry. You are correct. It's a fully grouted wall that we have, but then we're still using, composite wide flange beams and a composite deck for the roof system in order to, one, have the, dead load to keep it down, but two, also provide that missile impact that we're looking for next to structures that are taller. We have to, consider, layover, or let's call it collapse on top of this storm shelter structure.
Yeah, that part is wild to me. David mentioned that when we had talked to him, and that just blew my mind. That has to hold up another building that may fall on it.
Yeah,
but makes sense. Are there assemblies that are wood or steel that can stand up to the missile requirements? Like, is that possible or not really?
No, it is possible. So what I will say is, like I guess I alluded to earlier, Texas Tech has been very instrumental in a lot of developing what's ICC 500 and just even what could be used to pass for testing different, let's call it, construction assemblies. It's a free publication that they have put out that you can simply Google, and it's the debris impact testing at Texas Tech. It's a summer report on it, and it's prepared by their Wind Science and Engineering Research Center. I think it came out in early 2000s, but basically what they do, they have all sorts of construction, it's typical construction and not so typical construction assemblies. They have tested for missile impact. So what you asked, for example, is there a wood one that you can do? Sure, they have tested that. They've done, if you look through this, they've tested something that's 4 layers of 3/4-inch plywood with a 14-gauge steel insert with spacers. And they shot that 2x4 missile at it going 100 miles an hour. And then they will tell you at what speed at which that threshold, at what it meant, what it for it. So, and they have if you flip through this, it's like a PDF. It's pretty interesting to see what all they've tested. A lot of it has maybe a steel piece to it. Some have just multi-layers of, different grades of plywood. But you'll see some of them fail and they don't meet that 100-mile-an-hour threshold, or some of them do. And so if they have tested it, that, you can use that as backup as, well, here, look, Texas Tech has tested this construction assembly to meet this, and here's where it tested to. And as long as you kind of meet that, it should, that will at least get you the missile impact, requirements. After that, it's up to the engineer to design, whether it's, if you're using wood and the wood studs and all blocking for your plywood, to design for your horizontal pressures and to get that to work.
Okay.
So it's possible, but like I said, if you get bored, you can see the pretty exotic things that they have come up with.
Of course, I had to look. This catalog seems to have hundreds of different construction assemblies that have been tested by firing a 2x4 board, 15 pounds worth, out of a special cannon. I'll read you one here. Stud walls with polystyrene infill. 4 layers of 3/4-inch CD grade plywood with 2 layers of energy-absorbing polystyrene inserts. Missile speed of 100 miles an hour. Missile energy of 5,000 foot-pounds. Damage description: the full length of the missile perforated the target. This one sounds like a failure. What would you say, if someone is designing their first storm shelter? Let's make pretend I send over to you, hey, Mark, can you look at my plans? And you know that I've never done this. What do you think I would mess up on? What is the most common thing that people just kind of skip or specific to storm shelters?
So what I will say is the one thing that we've been kind of fortunate with is a lot of these storm shelters are still boxes. So they're not, you're not getting pretty exotic in terms of your design approach for these, whether it's the wall components, whether it's in plane or out of plane. So that to me is pretty easy. What I've found is that the thing that people get hung up on the most is, believe it or not, is the penetrations through the exterior envelope and how are we going to address them? Because like I said, all these things for the most part are going to serve as dual purpose. So you have doors. Well, those doors need to anchor per manufacturer's requirements. Mm-hmm. Well, those manufacturers have to do the same sort of testing per ICC 500 for missile impact and wind pressure. So they've tested their assemblies a certain way, assuming, making certain assumptions because, they're trying to meet a design standard. So whether you're trying to have, impact resistant windows, which we have used, they have their own. Yeah. So, they have their own certain requirements of how they're going to attach to your structure, and trying to see that interaction and that sort of coordination effort is the one thing that I see, that gets can be tricky when it comes to these things. One great example of it is storm shutters. There's only certain manufacturers that make these storm shutters. Well, not all of them are made to, not all of them are tested to attach to CMU. So when you're doing some of these some of these storm shelters, CMU may not be an option, because if you look at the manufacturer and what they tested to, some of it's just 4,000 PSI concrete. So you look at these cut sheets and there will be somewhere like a footnote or somewhere down on their, cut sheet, not available to attach to CMU because they haven't tested to it. It's not that it may not work. It's just that it doesn't happen.
All these tested systems have to be coordinated.
Exactly. And they've got a certain proprietary anchorage requirement. Well, believe it or not, I've had it come up to where, we locate our rebar a certain way. Well, the manufacturer, we didn't see their details until actually during construction, because this was one of the first storm shelters we did. Well, they ended up with their anchorage, the way they were going to do it within our CMU cavity, pretty much hit every single piece of rebar that we had going up. And you look at these requirements, a typical window, you think, oh, it's attached, every so often. Well, this window that we had, which was 4 foot by maybe, I'm trying to remember off the top of my head. It wasn't a big window, but it had 32 anchors on it, because it's got to withstand like 250, pounds a square foot of wind load, of wind suction, when you look at those components and cladding wind loads. Or it still has to survive a 2x4 missile hitting it at 100 miles an hour. So you got to look at what it takes to anchor these things by looking at these cut sheets, and then think of your edge details. And when you're, cutting these sections for, anchoring these things to it, the engineering of it, I would say, is, pretty simplistic, because a lot of times it is a box, but it's these fine details that I think that ends up tricking people up during design. Construction is a whole nother dish, whole nother deal.
All sorts can go wrong there.
Yes.
There's been an increase in awareness, it seems to me, for tornado design. So since 2007, we had modification of the F scale to the EF scale, severely damaging tornadoes in 2001, and generally more a move towards performance-based design. What do you think the future looks like for tornado design? Where do you see it going?
I don't know if it's going to go so much a performance-based approach, because you look at it, the way the tornadoes are approached, I guess it could follow I know seismic has gone that. If you're looking at high seismic, a lot of times with those systems, they do go performance based. But the grand scheme of things, when you're looking at this thing, you just want it to survive the tornado, because the tornado is such an extreme event. It's not like you want it to be, you want the occupants to survive and be able to exit safely after that. After that, the building has served its purpose. It's not intended, it's probably going to need to be repaired, or it could even need to be knocked down. But its intended purpose is just to life safety of the occupants for the duration and that short term afterwards. I think what I see going on with tornado design is, I think the more people are, living in these, let's call it live work communities, I think we'll see it, maybe start leaving. I don't think it'll become a code requirement to have it as a part of storm shelters, as a part of like more projects other than like the groupie that we're talking about and the essential facilities. But I will see maybe a lot of people, whether it's general public or developer driven, even maybe some of these office ones, since we've seen them going that route, I would see that maybe these people, it would start bleeding into that sector of life. And then, these people are wanting to have them as a part of their projects. It can be a great selling point, given some of these big office complexes that that are being constructed or, around the country.
Yeah.
Yeah. I think newer technology certainly comes in. Like I said, people would probably initially think, you're crazy to have like a window that's, resistant for this stuff. But you think about it, there's bullet resistant glass, so it's, the same kind of approach. There's new technologies that are coming on there. Like I said, ICF, I think, has been shown to be, insulated concrete formwork has been shown to be great for this, because you cut down the speed of forming a concrete wall surface by using that, block system. So you basically have a masonry concrete solution with a masonry approach. it's speed. It cuts down the cost of concrete forming, and you also have some exterior applications by having the insulation on there. So I think we'll see some new technologies. I'm not sure about, like I said, performance based. I think that's kind of sticking a little more to the high seismic because it makes more sense of having that fuse in there. Some of it is, I guess, maybe it'll push the envelope of having some connections of. I think right now everyone's design approach when it comes to a storm shelter is it needs to, while it can be close to, let's call it a host building, or but it always needs an expansion joint, because you don't want to, since the building needs to be able to be designed for breakaway forces. If it does have a hard connection, it can be so hard to quantify what that breakaway force is, or have an opinion of what that breakaway force is. We don't, currently we don't see much of that happening. So maybe you could go to a performance-based approach to where you're eliminating expansion joints by having some sort of performance-based fuse to have that connection. But I think that's a bit far-fetched to where
No,
go.
I think the logic there is right on, that it's not something that the building falls down, then you build a new building around your storm shelter. You crash it. So
I could also see this maybe future. I think it's seen this also go in somewhat the healthcare approach too, because currently right now hospitals, you do design them as immediate a risk category force, that kind of immediate occupancy type things, because the hospital does want to serve the community after an extreme event. So while they're certainly designed with a higher importance factor, right, but they don't fall in the regards of where they're required for a storm shelter either. So I guess it would not be surprising to see storm shelters bleed into that scenario as a part of a codified approach. Would probably be a next step that I could see. But yeah, that'd be probably about it.
Yeah, that's all the questions I got for you, Mark. Thank you very much for joining.
Yeah, thanks. Appreciate it.